Welcome to another recording for CSC 109, and this time our topic is network configuration in a Linux system. Now, before we get started, there are some basic terminology that you need to know for networking. The first would be hosts, and this is just the computer or device that is going to be on the network. So your phone, your laptop, your gaming system, your TV, all of those different things are hosts that are on the network. All right. Now you may say, what is a network? Well, it is a collection or two or more host computers that are able to communicate with each other. And again, when I say computers in this instance, again, devices. Doesn't necessarily have to be a specific computer. Now, your camera could be a host if it has a Wi-Fi and it's able to connect to the network. All right. Now, to be on this network, you could be over a wireless connection or wired. All right. Typically, if I have the option, I always suggest a wired connection. It causes less problems and is typically more reliable than wireless. But for ease of use, wireless obviously is king. You know, you just pull your phone out of your pocket and you're on the wireless network already. So it is a little bit of a give and take going on here. Then your mileage may vary. So you have to pick what it is that you think is best. All right. As I said, for super important things, Ethernet, hardwired, gonna be my better option. But for joy of simplicity and ease of access, wireless is definitely great. All right. Now, the network, being on a network, doesn't necessarily mean you're on the internet. All right, so you can have multiple computers networked together and they could not be connected to the internet. The internet is just an example of one very large network. All right, and it consists of publicly accessible networks that connect millions of hosts throughout the world. All right, so if you are connected to the internet, you're just on one very big network. All right, typically we think that as a WAN network or a wide area network, and that's kind of agreed upon by, if you look at your router that's in your house, there's a WAN port that you're plugging into. When you're on your house, that's the LAN port, the local area network. So we have two different networks that are going on here. You have your local one that's just internal to your house, and then you have the wide one of the internet and everything else. So a little bit of give and take going on here, and there are a whole bunch of other like intermediate steps between LAN and WAN. You've got PANs and MANs, and the list kind of just goes on and on. So just be aware of what type of network it is that you're connecting to, and are you connected to the internet or not. Wi-Fi, this is our standard term for wireless networks. We are on the wireless standard 802.11. All right, I think we are up to Wi-Fi 11 as of making this, not 11, sorry, Wi-Fi 7 as of making this video. And the higher networks and the Wi-Fi numbers go, in theory, the better speeds and things that you have the capability of getting, not necessarily that you're going to get, but the capability that the router could get to those speeds. Now, as a host, you're probably going to want to access something on the internet, and most likely you're going to talk to some sort of server, all right? And that is all a server is, a host that provides a service to another host or client. So it's just another device on the network, but it is offering out information. That could be websites, it could be maps, it could be applications, whatever the instance is, all right? So some examples here would be web servers that store, process, and deliver web pages. You have email servers that receive the incoming mail and deliver outgoing mail. Again, these lists just kind of go on and on and on. And more the world we live in is going to more and more server-based things. We have less requirements for things actually happening on the computer because our internet speeds are so fast that we can just purely rely on the internet for everything. And this is it's called SaaS, or software as a service. And this is very obvious if you ever used a Chromebook. A Chromebook basically has nothing happening on it other than a web browser. And from there, everything you do on it is on the internet. Now, newer Chromebooks can use the Android application store, but the original idea from Chromebooks was everything was off onto the cloud. You only had a web browser, and that was it. So, kind of interesting. Now, what type of service do we have? All right, so, or a service, I should say, is a feature provided by our host. All right, that's what a service is. An example of this would be web pages or email servers, those types of things. Those are services that a server is offering to you. All right. Another one would be Microsoft Office. I mean, if you, with your HCC email, you can have Word, Excel, PowerPoint, all in the cloud, all in your web browser. So that is something to look at. Next, we have clients, and this is a host that is accessing a server. All right, so when you're working on the computer, surfing the internet, you are considered to be on the client host. All right, so again, you're the one that's making the requests. You're telling Amazon.com, hey, show me this website. You are the client, they are the server. All right. And then one of the more important network terminologies you might hear is the router. And this is the device that directs your computer traffic to its destination. All right, so it's saying, all right, this computer is looking for Amazon.com. So we have our computer here. All right, and that's you. Here, let's call this computer. You have Amazon.com here. and your computer says, hey, I need to talk to Amazon, and it sends a request to your router. All right. And your router says, okay, I need to send that to this router, which then needs to send it to this router, which then needs to send it to this router, which then says, oh, Amazon's right here. All right. So all of these are routers. They are all directing your information. And all of these routers are connected to other routers, which are connected to other routers. So your router is trying to connect you to the best way to a specific place. All right. And all these things may be interlinked, or they may not be, depending. And your path, whether you like it or not, may go from you to here to here to there to here to there to there. That may be your path to get to Amazon, instead of taking the most direct route, which would have been here to or like that. All right. And it all just comes down to how that router is managing traffic and all those other fun things. So a router is another big terminology that you might need to hear. All right. Another one is a switch. All right, and that's just part of your standard home router. All right, so if you have your standard home router, all right, if you look at the back of it, got our little ports back here. All right, you have one port there, that would be your WAN port, and then you normally have 4 ports chained right next to each other. Those are your LANs. All right, and those 4 ports are really just a switch. So it's just a way of connecting multiple devices together. Your home router also normally has antennas sticking off the back of it. All right, and those are your access points. All right, if you go to industrial settings, or if you're on each campus, you look at the ceiling, you'll see little square white boxes with blue lights on them. Those are the access points. In your house, it's all part of this one device. So just something to be aware of. All right, so some features for the terminology. We have packets, and this is how we send information between hosts. All right. So you make your request to Amazon. You're saying, hey, I want this web page to show up. And you send that packet of information to Amazon. Now, that could be one big packet, depending on how large the packet is. Or if the packet's too big, the information, you're asking for more information than you can send, it may break it down to multiple packets. If all you're asking for is a website, that request at least could probably, and is probably one packet, maybe 2. I'm guessing here. I'm not a networking, mastermind. But if you're trying to download a large file, then it's not going to be able to all fit in one packet. So we take it, we break it down into multiple smaller packets. And this is for reliability. If you have one big packet, right? You have one big thing that you're trying to download. And all of a sudden, that file gets corrupted. It's trying to say ABBA, whatever the code is. And instead of ABBA, it's ACA, A. Well, all of a sudden, that packet's now corrupt. That whole file is now trash. And we have to send that whole thing again. But if we take this and we break it down to a whole bunch of small little packets, and we send those out at a time, and one gets corrupt, well, now we want to resend that one packet. We don't resend everything. So it's really useful being able to have these packets and be able to send one thing at a time. Now, you also have your IP address. All right, we are going to talk a little bit about this more later, but an IP address is your internet protocol address, is a unique number assigned to a host on a network. And in a nutshell, hosts use these numbers to address network communications. So basically, this is your street address on the road that you live on. That's what your IP address is in a nutshell. And again, we're going to come back to IP address in a little bit. You also have a mask or a subnet mask or net mask. All right, they're all the same thing. And this is just a system that's used to define the IP address considering on a single network. So I'll just give you a quick example here. Your IP address of your home computer would be 192.168.0.100. All right. And the subnet mask would basically tell you that these first 3 digits, this is the road that you live on. And then this last digit is the address on that road. Okay. That's all the subnet mask is doing. So again, we'll kind of talk more about this in a little bit. We also have host names, all right, to make life a little bit easier. Just like you go to Amazon.com, instead of 59.68.32.148, trying to memorize all those different things without being close would be really hard. So we use host names to allow us to do this without being as complicated. So they're easier for us to remember than numbers. It'd be much easier for you to say, call my friend Bob, than for me to say, call whatever his phone number is. So most of you probably also who are watching this don't have phone numbers, remember, because you just have a contact book in your cell phone. Back in the day, you used to have to remember your friend's cell phone, not cell phone numbers, home phone numbers, and you would have to just manually dial them in on the phone. So kind of an interesting one there. We also have URLs, which are uniform resource locators. This is like a host name for a website. That's what this really comes down to. So host name, this is for a specific computer on your network, where this URL is basically again the host name for a web address. So again, this would be like Amazon.com. This would be Bob's computer. So the host name would be Bob's computer or whatever it is that you named your computer, and this would be a website name. All right. Yep. So makes our life a little bit easier. It's what you type in the web browser access web page. So again, this would be like Amazon.com. It does also include a protocol. All right. Most of the time, the protocol we're using is HTTP, and S is nowadays the protocol. All right. We didn't used to have that S. Everything didn't used to be secure, but now basically every website is secure. All right. Going along with your IP address, we have our DHCP, which is your dynamic host communication protocol. All right. And this dynamically, or like on the fly, assigns IP addresses to the hosts that are connecting to the network. All right. This is sometimes random, sometimes it's done by MAC address. It really depends on the router that you're using. So just kind of something to be aware of. To go along with that DHCP, we have not DHCP, the URL. We have the DNS, which is the dynamic naming system, or domain name system, and this basically translates the IP address. The domain names of URLs into IP addresses. All right. So when you would type Amazon.com in, because we don't know the IP out there, Amazon.com, that gets sent to the DNS server, and then that responds with, oh, that's at 52.94.36.100, 5. All right. So again, that way we don't have to remember it. The DNS is basically a glorified phone book for the internet. That's what it comes down to. All right. We have Ethernet, which is a wired network environment, and this is the most common way that we connect multiple devices together. This uses an RJ45 connector normally, which is 4 twisted pairs. Traditionally over Ethernet, we're at like standardizing 1 gigabit per second now, which we can go faster than that. And I'd say most computers, there is no need for 1 gigabit internet speeds. 100 meg, that's plenty for most applications. And the last thing on this list is TCP/IP. This is our transmission control protocol / internet protocol. And this is a fancy name for a collection of protocols that are used to define how network communication should take place between hosts. And while this isn't only a collection of protocols used to define network communications, it's the most often one utilized. So it's TCP/IP is kind of what makes everything go in the world that we live in. All right. Now, IP version 4. All right, so we're going to come back to IP version addresses. So there are 2 different IP version addresses that we are dealing with in the world today. IP version 4, this one at the top. All right, this is probably the go-to one. It is still overall the standard. IP version 6 is starting to slowly work its way into things, but IP version 4 is definitely the king of kings right now. All right. The problem with IP version 4 is we are running out of IP version 4 addresses. So there's too many different things that want to be on the internet at the same time. So we said, okay, we're going to have to come up with a new system. So they started developing IP version 6. All right. So IP version 4, all right, uses 4 different numbers, and they're all 8 bits. So we have 32 bits total here. All right. And each section, section 1, section 2, section 3, and section 4. Each one of those is a number between 0 and 255. All right. Now we have taken that range, the IP version 4 ranges, and we have broken them down into different sections per se. So it's a little bit of a give and take going on here. All right. Now we have, as I said, 32 different bits. That is 4,294,967,296 different IP addresses. So we're just going to say, 4 billion. All right. Can you believe that we are running out? All right. And if we truly gave every device, every phone, laptop, computer, its own dedicated IP address, we would be out by now. All right. That's just how it is. There wouldn't be an option there, because if you think about how many devices you own, right? So, in my house, I've got, I think, 30 different devices on my network. When you start talking about smart speakers and home automation and TVs, game systems, phones, tablets, computers, and all those things, I've got like 30 some devices on my network at home. So that's a lot, and that's for one, so again, call that for a family of 5. So in my family, each person has, say, 6 devices that need an IP address. But we have over 4 billion people in the world. We would need, 32 billion or something, some crazy number of IP addresses. All right, so IP version 4, this is basically in the long run plenty for all home and business needs. All right. The problem is, for your local traffic, your LANs. All right. So for LAN, IP version 4 is perfectly fine. The problem is when we start getting out to the wonderful world of the internet and everyone wanting to have their own website and this and that, and the list goes on and on and on. That's when we're running out. That's the real big problem. And that's where IP version 6 is starting to come in. Again, it hasn't taken over. It hasn't really set foot. Been locked in yet, but it's definitely, we're getting there. All right. So just kind of something that you need to be aware about. IP version 6 is starting to come. That is 128 bits. So 128 bits. We went from 32 to 128. Right. So that would be, 3.4 times 10 to the 38th. 3.4 times 10 to the 38th, was that I said? Yep, 38th power. All right. So if we look at billion, all right, that was what? Yeah, so the 10th, 9th power, something like that. So yeah, we're really getting up there. 2 to the, what was it? 32. So 3, 6, 9, 4 times 10 to the 9th. All right, so we're 29 times 10 to the 29th time is bigger than that. So there are a lot more IP version 6 addresses to the point that that should be plenty for the years and years and years to come. The problem is it's just not, it hasn't become fully accepted yet. Everyone's not using it, which causes problems. All right, and that's why we need porting. So porting is when we switch from one technology to another. So IP version 4 and version 6 aren't directly compatible. So we need an intermediary to convert IP version stuff to IP version 6. So a little back and forth that goes on. All right. And then the last thing on this screen is the NAT. All right. This is net address translation. And this is how you share your one internet connection at home with every device on there. And just again, something that you should really in the long run be aware of. All right, so how do we configure our network devices? All right, so how you're configuring it, whether it's wired versus wireless, is going to make a difference. Right? Wired devices, basically you plug in and it says, here's my IP address and you're good. All right, and as long as your MAC address isn't banned from the system type of thing. Wireless, on the other hand, there is a lot more that you need to be aware of. It's like, okay, what's the wireless name we're connecting to? What security protocol is it using? How do I verify that I'm supposed to be on here? Is it just a straight up password? Do I need to give my username and password for my Windows account? What's going on? All right. So there's a lot of different things that are going into that wired versus wireless bit when you're doing configurations. Wireless is a lot harder to configure than wired. So definitely something that you want to keep in mind. The other thing is we have DHCP and static. So if I think I already said this, DHCP is Dynamic Host Communication Protocol. All right. So that is how IP addresses are assigned. So if you don't have, if you're getting on the network, that's first time there, and doesn't know your MAC address, you're like, hey, I need an IP address. DHCP is what gives you that IP address. All right. If you have a static IP address, when you plug in, you're like, hey, MAC is this. Here's my IP address. The system goes, cool. Have a nice day. And everything works fine as long as everything is set up right. The other thing I like to point out with static is there's 2 different ways to do static. All right. There's the 100% static option, which is setting it on the host itself. So, if this is my computer and you say, hey, here is my IP address, blah, 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 blah. All right. And when you plug in, that's what you try and talk with. All right. The other option is you talk to the DHCP server and you say, hey, here's my MAC address. And the server's like, oh, that's right. You get this IP. All right. So the DHCP server is saying this MAC gets this IP address every time, no matter what. So it's saving that IP address for that device when it connects on. To me, it's definitely easier to manage on the DHCP side of things, having that manage all the devices and all the static IPs. But it really comes down to your personal preference if you're the one setting this up. All right. Yep. Also, when you're doing this distribution, it depends on when you're doing the networking setup. It does depend on your distribution and what applications you have installed. It used to be ifconfig was kind of like the go-to option, and that's becoming kind of outdated at this point, replaced by IP. So there's different things that you do have to consider. So there's not a one thing fits all. Now, if you have the same application installed on every system, that's the network configuration application, then yeah, it's much more standard for you. But it's just something that you do need to keep in the back of your mind. All right. Also, you have your DNS, which I already said was the domain name system, and it's the Internet Phone Book. All right. But you can state what your DNS is. You can say these are the DNS servers I want. All right. A few of them that I know, we have Google's, which is 8.8.8.8. They also have 8.8.8.4. You also have 1.1.1.1. Those are all different DNS server. These are both owned by Google. This one is a different provider. I forget what one that is. But you can go search them and figure out which provider it is that you want to use if you want to set it up that way. All right. Now, when it comes to name resolution, all right, there are three critical files. That's the etc host, the etc resolve config, and the etc nsswitch.conf. All right. The host one contains the table of host names to IP address, and it can be used to supplement a DNS server. All right. So if I would do that over here on my Linux box right now, /etc/hosts, you would see what's going on in there. So not a whole lot going on in my file there. All right. The resolve.config contains the IP address and name servers that systems should consult in any attempt to resolve names to IP addresses. And these servers are often DNSs. So let's just go ahead and take a look in there. etc/res. Let's see. Yeah, there we go. I can cheat that one out. All right. So again, in this one, I actually have nothing. This is all comments in here. All right. I guess down here we have the name servers and then options. All right. So a little bit going on there. And then the last one is the nsswitch.config can be used to modify where host names lookups occur. All right. And let's just go ahead and see what's going on there. And my window is not maximized correctly. There we go. All right, so we can see what's going on in this file. Again, not too much going on in the long run there. So a little bit of give and take going on. All right. So overall, the process here. All right. So applications request a connection to a remote computer. First, so when you're saying I want to talk to Amazon, or I want to talk to Joe's computer next to me. All right. First, the NSSwitch file is consulted, and it looks for files and directs the computer to check local files to resolve the host name. So it's basically saying, hey, are there any files in here? Is this saying I should be checking anything? So right here, I believe it's saying, hey, go check these things. And here it says not found, return DNS. So it says if you can't find it in there, go to the DNS. All right. Second, the file is I'm going to go to the host file and to attempt to resolve the name. The name matches an entry in the host, it's resolved. If not, it will fail over or continue to the DNS option, even the resolution is inaccurate. This can occur if the entry in the host points to the non-assigned IP address. All right. And then third, if both those other options failed, the local etc host file doesn't reach result a match, this one will use the configured DNS server entries contained in resolve.config to attempt to resolve the name. All right. So again, a little give and take going on here. Now, some networking tools. So let's go ahead and just clear our screen. We have ifconfig. All right, now everyone's screens are going to look a little different here. All right, I am on a Proxmox server that has a whole bunch of stuff going on, so that's why I have a whole lot of interfaces. I'm not sure why I have so many on this virtual machine, but that's what's going on. Normally you'd have one Ethernet, right? So here's my Ethernet, and here's my IP version 4, so 192.168.0.116. Here's my netmask, which is 255.255.0, and then here's my broadcast, which is 0.255. All right. And then you also normally have some sort of loopback, all right, which is normally 127.0.0.1. Netmask here is 255.0.0.0. All right, so that's ifconfig. This displays interface. It's ifconfig is interface configuration. You can limit this to 1 if you would want to. This displays network configuration information, includes IP version 4 or 6 and or 6, subnet mask information, backend received and transmitted, multiple AMPS interfaces, and as I said, it is starting to become obsolete. It is overall being replaced by IP. So if I do IP ADDR for address, all right, and again, we get that same information overall, but here is our loopback. All right, and then here is our other one. So you can see 1 is our loopback, 2 is this one, and there we go, that same information is being shown to you. All right, so IP address is starting to replace the ifconfig. This also is starting to replace root and ARP, which I'm going to talk about root in a second. So root shows the path to other network devices where information is sent depending on their destination. Now, for my home server setup, root is pretty boring. All right, so I've got one default, and I've got 2 local linked locally, and then linking to my local address, my router. So nothing too crazy is going on there with my home stuff. All right, another super handy option is ping. All right, and we could say ping amazon.com. And the first thing it is, it says, hey, here's an IP address for Amazon.com. And now it's sending a ping request to them. All right. And it is telling us our time. So here it's 9 milliseconds, 9, 10, depending on one. That's how long it's taking to get those back. So, and by default, that just keeps going on and on and on forever. I believe it's ping, come on, -C, and then say 5. Oh, I gotta put a space there. There we go. 1, 2, 3, 4, 5, and we're done. All right, so that's how you can limit it to how many you want. We also have netstat. All right, we're going to do -TLN. T is TCO, L is listening. I'm sorry, TCP. T is TCP, L is listening, N is the numbers. Oh, I did not start. Why did that not work? Here we go. So here is what's going on. We got my TCP stuff. Here's the version 4. There's version 6. Here's the IP addresses. All right. So the ports that are open right now, 53 is standard for DNS, 22 is SSH, and 631 is for Internet Printing Protocol. So kind of interesting that that's open up on my computer. I really don't need that open, so I should really go close that port now. All right. We have SS, that's going to display dump stock statistics, which for me is an absolute boatload of stuff going on here. All right, again, this is a VM machine, so I don't know what else is going on there. It's purely used for this class, so it shouldn't be anything too crazy. All right. But this shows information similar to netstat. It can display more TCP and state information than other tools. All right, so something to be aware of. And some of the columns that you'll see in here, you'll have the network ID, you'll have the state, the receive queue, which is the amount of data queued up for being processed having been received, send queue, which is the amount of data queued up for being sent to another host. You have the local address, you have the peer address, those types of things. We have the dig command, and this is the domain information grouper. All right, again, there's a lot of stuff going on here. All right, and this is just used to test the functionalities of a DNS server. So I could do like dig amazon.com. I know I just default to Amazon, and here it's telling me like, hey, here's some IP addresses for amazon.com. All right, we can also do the host, same thing with hosts. We can do host, and I'm going to do -4. That's for IP version 4 only. I'm going to do amazon.com again, just to keep things consistent here. And again, it's showing me the same 4 IP addresses. All right. Oh, here, if you're doing anything with Amazon Mail, it's handled by right there. So that's giving you some other information. And then last but not least, we have SSH. Now, right now, I am SSH'd into this. All right, so I use PuTTY to connect to this remotely. All right, so I can't really show you great SSH right now, but this is used to remotely log into a Linux machine. It's just terminal access, so if you want a nice GUI, this is not going to be your go-to. And the other thing is just to be aware of is when you first log into, it's going to show like you a key. It's called an RSA, and this just makes sure that the machine that you're logging into is the one that you think you're logging into. Now, the first time you log in, you have to say, yes, I'm willing to connect to that machine. And then every time after that, it doesn't ask you. But if that RSA were to change, like you try to connect to the same IP address with the SSH, that RSA was different, it would throw up a warning like, hey, this changed. Are you sure you want to connect to it? And the only reason it should change is if you personally like updated the machine, replaced it, change the server around, whatever. So it really shouldn't change. And if it changed for no reason, that could mean that someone else is duplicating your server and trying to make you think that you're logging into your own equipment when you're not. So anyway, that's kind of some basic networking information.